Okay, so today we are looking back at properties of rational exponents and radicals. So up at the top, I have all of the properties, and I have them listed out. So products of powers means if you have two of the same base being multiplied together, you add the exponents. If you have an exponent to an exponent, you multiply. If you have two things inside with the same exponent, the exponent is given to each of them. If you have a negative exponent, it turns it into a fraction. Zero exponent turns every single number into 1. If you have two of the same base and they are being divided, you can subtract their exponents. And then if you have two things being divided raised to the same exponent, you can also distribute the exponent as well. Okay. So number 1 wants me to use the properties of rational exponents to simplify each expression. On number 1, I just want to add my exponents together. So I'm going to add 1/4 to 1/2. So I can go ahead, and if I go to Desmos, I can do 1/4 plus 1/2. Ooh, not like that. Like this. And then if I press the square over square, it turns it back into a fraction. So when I say square over square, I mean this picture right here. That I didn't know what I was talking about. So anyways, it gets me 3/4. So my answer here is x to the 3/4. For number 2, I want to add, no, because these are two different letters. I want to distribute my exponent to each of the insides. So I'm going to have x to the 1/2 times 2 and y to the 1/3 times 2. Then I would just multiply. 1/2 of 2 is 1. And then over here, 2 times 1/3 is 2/3. So I could leave it like that, or whenever something has an exponent of 1, we don't have to write it. Okay. On number 3, same idea. I want to distribute my exponent. So I'm going to have x to the 5th times negative 1/5 and y to the 5th times the negative 1/5. So I can go to Desmos and multiply 5 by negative 1/5. Which gets me negative 1. So both x and y are going to have negative 1 as their exponents. Okay. So what I can do is I write 1 on top of a fraction as a placeholder, and then I'm going to have x and y move to the bottom because both of those had negative exponents. Number 4, I have the same base being divided. So I have an exponent of 1 on the top and 1/3 on the bottom. When it's division, it's subtraction. So I have 1 minus 1/3 as my exponent. So I can go to Desmos and do 1 minus 1/3 which, if I turn back into a fraction, gives me 2/3. On number 5, I want to go ahead and distribute my exponent because they're two different bases. So I'm going to have x to the 1/3 times 2 over y to the 1/4 times 2. So 1/3 times 2 is 2/3. And then on the bottom, I'll use Desmos for this one. One-fourth times 2 is 1/2. Number 6, I want to go ahead and, because they have the same base, the exponents get added. So I'm going to have 3/4 plus 1/2. So I can go back to Desmos and add these. Which gives me 5/4. So the next thing we're going to talk about is properties of radicals. So the product property states I can multiply the numbers inside if they have the same radicand, the little tiny number up here. And I can split them up as well. And I can do the same thing with division. I can either divide them or split them up into two separate ones. So number 7 has two of the same radicand. So what I'm going to do is I'm going to rewrite this under one giant radical. And I'm going to have 12 times 18 there. Then I want to go to Desmos and figure out what 12 times 18 is, which is 216. So I want to find the cube root of 216. That means I want 3 of the same number. So if I do my factor tree for 216, I can see it's even. So that's going to be 2. 216 divided by 2 gives me 108. 108 divided by 2 gives me 54. 54 divided by 2 gives me 27. 27, I know, is divisible by 3. And 9 gives me 3. So I'm looking for groups of 3 here. I have 1 and 2 numbers that have groups of 3. I'm going to take 1, 3 and 1, 2 and multiply them together to get 6. I have nothing left over at my branches, so nothing goes inside a radical. Number 8. Since they have the same radical in their fraction, I can rewrite it as one giant fraction, so I can have 80 divided by 5. Which gives me 16. And then I want to factor tree 16. That's off my screen. So I have 2 and 8, 2 and 4, and 2 and 2. Because of my index, I'm looking for groups of 4 of the same number. So I have 4 2s. So this one comes out nicely as well. This one is just 2. Okay. Number 9, I want to multiply my inside numbers here. So I want to do 27 times 3. Okay, that will give me 81. So I want to factor tree 81. I know this one is 9 and 9, and each of my 9s can break up to 3 and 3. I'm looking for 4 of the same number, which I have. So my answer here is just 3. Sometimes it doesn't come out nicely. So on these ones, I can factor tree still. I'm looking for groups of 3 of the same number. So 135, I can see it ends in a 5. I don't know what the other number is, so I'm going to go check on Desmos. I have 135 divided by 5, which gives me 27. Then 27 is 3 and 9, breaks up to 3 and 3. So I have 3 of the 3s. 3 will go out front. And then I have this 5, who doesn't have any friends, so he has to stay inside. Okay, so on number 11, I could rewrite it as one giant fraction, but 7 and 8 isn't going to simplify. So what I'm going to do is I'm going to try to get rid of the radical on the bottom. First thing I want to do is I want to factor tree 8. So I have 2 and 4, 2 and 2. Notice I have 3 2's on the bottom, but I need 5 to get rid of the 8. So what I want to do, or to get rid of the radical, what I want to do here is I'm going to multiply by the 5th root on the top and bottom. And I need 2 more 2's, so I'm going to multiply by 2 squared. The 2 that's the exponent is telling me how many more 2's I need. What? I'm sorry. Yeah. So the base 2 is the number that I had 3 of. And the exponent of 2 is I need 2 more 2's to make a total of 5. So what I want to do is I can rewrite this. I have 5th root of 7 times the 5th root of 8. 2 squared is 4. So I'm going to rewrite those as 4's. Okay. 7 times 4 is 28. 8 times 4 is 32. Then I can go ahead and factor tree 32. So that gives me 2 and 16, 2 and 8, 2 and 4, 2 and 2. Notice now I have 5 2's. So I can get rid of this radical on the bottom. It's just going to turn into a 2. Questions here? What do you mean? I did times it by 2. 2 squared is the same thing as 4. Oh, no, I was just rewriting it. Because this right here? Yeah. Because it's inside the 5th root. So this one doesn't have a 5th root, so I can't divide. Only when they have the same symbol up front. Okay. Number 12. This one, I can't do anything with 3/4, so I'm going to split it into 2 separate 5th roots. So I'm going to have the 5th root of 3 over the 5th root of 4. Then I can factor tree 4. It's 2 and 2. I need a total of 5 of the same number. Currently I have 2, so I need 3 more 2's. So I have the 5th root of 3 over the 5th root of 4. I'm going to multiply it by the 5th root of 2 cubed, because I said I needed 3 more 2's. So remember, 2 cubed is the same thing as doing 8. So 3 times 8 is 24. And 4 times 8 is 32. Which, remember, we factor treed off to the side over here that's being cut off my screen. So I could just rewrite this as the fifth root of 24 over 2.
Will you always factor 3 the bottom?
Because you don't like, in math, it's not proper notation to have radicals on the bottom. This one happened to be 2 both times because that was the number I had on the bottom.
So it's whatever number that you have on the bottom.
Any other questions here? Okay. The last few want me to simplify each expression, so I'm just combining like terms. Notice both of these have 4th root of 10s, so this one has a secret 1 out front, and all I'm doing is I am adding that 1 to the 7. So that gives me 8, and then the number inside the radical stays the same. Okay, same thing with number 14, even though those aren't written like that. I have the same base. I have 8 to the 1/5, so I'm just going to combine the 2 outside numbers, which give me 12, and then the inside part stays the same. Okay. Notice on number 15, these are not the same number. So what I need to do is I need to factor tree 54 so I can get the same number. 54 is even, so I'm going to get 2 and 27. And then 27 goes to 3 and 9 and 3 and 3. This one is a cube root, so I'm looking for 3 of the same number. I have 3 3s, so that will go on the outside. And then the leftover number 2 stays on the inside. Now I have minus cube root of 2. There is a secret 1 out front. So I want to do 3 minus 1, which gives me 2 cube root of 2. It will give you a decimal on this one. If it gave you a nice whole number, yeah. But number 16, I want to factor tree my 40. So that's 2 and 20, 2 and 10, 2 and 5. This one is, again, looking for groups of 3 because of the little number right there. So I have 3 2s. That will go on the outside. And then I have this 5 left over on the inside. And then I was originally adding it to the 5th cube root of 5. So this one had the secret 1 out front. So I have 1 plus 2 gives me 3 cube root of 5.
We were out in the field, and this was really like this. And that made a comment, but I thought I made it in my head. I was like, who's that blueberry? I was like, who's that blueberry over there raising their hand?
Okay, so number 17, I want to add my exponents. So I want to add 1/3 and 1/6. Which gets me 1/2. On number 8, I multiply the exponents. So I'm going to have y to the 1/5 times 5 and w to the 1/4 times 5. 5 times 1/5 gives me 1. 1/4 times 5 gives me 5/4. So this is just y w to the 5/4. Number 19, I distribute again. So I'm going to have x cubed times negative 1/3, w cubed times negative 1/3. 3 times negative 1/3 is negative 1. So this is going to give me 1 over x times w. On number 20, I have a secret exponent of 1. I want to go ahead and subtract my exponents. So I have 1 minus 1/9. Which, as a fraction, is 8/9. Okay, number 21, I want to distribute that 3. So I'm going to have x to the 1/6 times 3 over y to the 1/4 times 3. So I want to do 1/6 times 3, which gives me 1/2. And then I want to do 1/4 times 3. Which gives us 3/4. Number 22, I want to subtract, so I have 1 minus 1/4. Which is 3/4. Questions here? Go back. It wants me to use properties of radicals to simplify the expression. So on this one, I first want to start off by multiplying the 4 and the 128. Which gives me 5/12. So I can factor tree 5/12. It's even, which gives me 2 and 2 56. That breaks down to 2 and 128, 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So this one I am looking for groups of 3. I have 3 groups of 2, so I would multiply 2 out 3 times, or I could write 2 cubed, which gives me 8. On 24, I want to rewrite as one giant fraction, so I'm going to have 192 divided by 6. Then I want to actually divide 192 by 6. Gets us 32. I want to factor tree 32. Gets us 2 and 16, 2 and 8, 2 and 4, 2 and 2. I was looking for groups of 5 of the same number. I have 5 2s. So my answer here is just 2. On number 25, I want to rewrite as one giant fraction. I have 250 divided by 2, which simplifies to 125. I can factor tree 125. It gets me 5 and 25, 5 and 5. So I have 3 5s. My answer is just 5. Okay, number 26, I want the cube root of 500, so I'm going to factor tree 500, which is 2 and 250. 250 is 2 and 125. 125 is 5 and 25, and that gets me 5 and 5. I was looking for 3 of the same number, so 5 goes on the outside. I have 2 2s left over, so I do 2 times 2 on the inside, which is 4. Number 27 is number 24, so I'm going to skip that one. Number 28 is the cube root of 104, so I want to find my factor tree. I'm going to have 2 and 57. 57 is 3 and something. $19. It wasn't 57, it was 52, wasn't it? Just kidding. 52 is 2 and 26. 26 is 2 and 13. So I have 3 sets of 2, or 3 of 2. So that goes on the outside. 13 goes on the inside. Okay. Number 29 is combining like terms. So I put a 1 out front, and then I add the 1 and the 9 to get 10. 6th root of 17. Number 30, I want to add the 5 and the 6 to get 11 times 7 to the 1/3. Number 31, I want to factor tree 48 first. So I get 2 and 24, 2 and 12, 2 and 6, 2 and 3. I'm looking for 4 of the same number. I have 4 2s. So I have 2 on the outside, 3 on the inside, and then I'm subtracting a 4th root of 3, which, remember, has a secret 1 up front. 2 minus 1 is 1. I don't have to write the 1. It could just be 4th root of 3. Number 32, it has a secret 1 out front, so I have 7 minus 1 gives me 6 5th root of 12.